In this Algebra Balance Interactive, you will explore two-step equations. You will explore what it means to solve an equation algebraically. While keeping both sides of the equation in balance, you will use different strategies to find its solution. Think about why a balanced scale is a metaphor for working with algebraic equations. Perform the same operations on each side to see how the quantities change. You will record in this investigation three things while you notice and while you're working on the balance. Take screen for your examples. In this equation, the solution log will keep track of each step that is performed on the pan balance. In this equation and on the balance, you will notice that all blocks are red. Pay close attention to what happens with the negative x at the end. When solving an equation, you will work with the order of operations in reverse. To undo the subtraction minus 15, you will need to add 15 green blocks. I can move one block at a time, which will create a zero pair, and for every one red block and green block, it will create a zero pair and disappear. I can also move several blocks at the same time, and the pile of blocks, 14 greens and 14 reds, will all disappear at the same time. In order to keep the pan balance equal and balanced, and also keeping the equation balanced, I need to do the same operation on the right. I can move one block at a time, or I can create a pile to move at the same time. We will notice that the red blocks disappeared, but I am left with a positive 4 that will keep the balance and also keep the equation balanced. I also want you to notice that the solution log is keeping track of every step in inverse operation that is performed. To continue, I need to solve for x by choosing the appropriate value to divide by. I will group the tiles within the grid to find the value for x. In my equation, negative 4 times x equals 4. So the order of operations working in reverse, I have to work with undoing multiplication or division next. I will use the slider and divide by 4, and it will create groups that I will move my x's into. I will create the same groups in the grid on the right. I can see that negative x is equal to 1 block in the arrangement on the grid. But in order to solve the equation, I need to figure out not a negative x, but a positive x. So there's one more button that will help in order to solve the equation. Negative x, I need to think about answering using the opposite. I don't want a negative x to represent my answer, so I'm going to use the negative 1. This is the same thing as dividing by a negative 1. This is creating the opposite of my answer. And all x's and all blocks have changed to the opposite. And I can change that back. A negative x is equal to a positive 1. But in order to answer, I need to show that a positive x is equal to a negative 1. Be careful when you're working with negative x's in your equation. So for my final answer, I can see that the solution, I've been able to isolate x is all alone. Positive x is now equal to a negative 1, which will be my solution, negative 1. I can check to see that my equation and pan balance has stayed equal. When I can check a negative 1 in my equation, I can work with negative 4 times negative 1, which is positive 4. A positive 4 minus 15 would create a balance of negative 11 on the left, and it would be balanced with negative 11 on the right.